Hello, everyone. My name is Wycliffe Agumba Oluoch. I'm a postdoc at the Land Economics Group here at the University of Bonn. The reason why I'm making this video is to help um, those who are new to the use of species distribution model, which was built by Babak Naimi. And he did a video of the kind of a demo of the package in 2020 during the um, ENM 2020 course, which was organized by Town Peterson. And many people have been going back to that YouTube video, getting the code and trying to run in their systems and facing a lot of errors. So this is because the package itself is a living thing, like it grows and it changes over time. So a lot have changed since then, since 2020 to date. And if you just pick that code and rerun it today, oh, of course, many things have changed and you are likely to face a lot of errors. This is the official biogeoinformatics YouTube channel for Babak, and he hosts all the package information updates, and it's super active. Like in the past 2 months, there was update. This is the official GitHub repo for the package, where you are welcome to go and check whichever function you are trying to use, and it's throwing some errors. You can get what really happens uh, under the hood or in the code base itself. He also has a website called Biogeoinformatics, where he did an example uh, quite a while ago in 2016, last updated in the same year. And of course, most of the code here still nowadays don't work. For example, we probably no longer have RGDAL in CRAN, on CRAN. But a very important thing on this page is that you are able to join the community using SDM by a link which is down below the last line of this on this page. So if you want to join the community in the in the Gmail platform, then you can join by clicking that link if you have Gmail account, and then you will be able to share your problems with the community and get helped. Okay, so another thing which I wanted to let you know is that if you go to CRAN, you will get a very, very important document, which is SDM. If you go to SDM on CRAN, you will find this sdm.pdf, which is quite recent, like just updated early this year. And it has got all the information on updates that have occurred on this package. So whenever you are stuck or a new thing has popped up, then it's well documented in this. And there's a great effort that Babak and his team, he did this with Miguel Araujo, Professor Miguel. And they have made a lot of effort to ensure that every function in the package is well documented with examples that you can reproduce. So this, I encourage everybody who wants to really use SDM in their day-to-day activities or modeling workflows. Please, this should be your most important or most valuable reference point. And then, of course, the community is there for you. Okay, so let's get into the code which he used in this video, and then we see what has changed. All right, so as you can see, it was script for ENM online course, which was organized by Peterson. I've said that, and a very big team was involved in this that helped to build it. I'll be a bit fast, so because I will also host this script here on GitHub, and I will provide link below this video. so that anybody who wants to reproduce it can just go and pick that link and run it. So when he loaded in that YouTube SDM package, and that has not changed. So the name of the package is still SDM. And if you check package version that I'm using now, it is 1.2.56. You remember when we checked on CRAN, we saw that the version there was 1.2.55. So the one I'm using is the development version. So that is normally retrieved directly from the GitHub. So if you go to the GitHub repo, SDM, you will see this code here, which is DevTools, and then install GitHub Babak Naimi SDM. So here is where every development version of the package is, which is one step ahead. That was because there was a small bug in the 5.5 where a data frame could be adding another column of RID. We'll see that probably, but since I'm using the latest version, which is 1.56, we may not encounter that problem. 1.2.56. So that has not changed. For me, I will not need Dismo. dplyr I will need. tidyr I will need. MapView, I will still need that. In addition to these, I will need another package called MapEdit. I will show you why. And we will see which one I will also need. Oh, very, very important is geodata. I will need geodata for sure. So thanks. I really appreciate those who built geodata package. If we look at the citation of geodata, yeah, we get to know the team behind this. Highly appreciated the effort they made to render a lot of data easily accessible using this package. So I've only blocked out Dismo. Of course, we will also need USDM for the multicollinearity stage. Now here he used GBIF to check the availability of this species. But for me, I will use SP occurrence, which is from geodata package. So I can directly use that to check the occurrence, and I see the number of records. And for this, we provide genus, and we also provide species. Then you can specify download as false or true. We get over 7,000 records for the species. And to save it in this object, we just again call the same function we had there. But now setting download to true, which means now we want the data to be grabbed from GBIF and brought to our computer. This might take time depending on the speed of your internet. Working now in a rather stable internet, so all the 7,347 records are obtained. Checking the class of SP remains the same. It's still data frame. Like class, the function class has not changed because it's from base R. Dimensions did not change. We still have so many columns on the data from GBIF. And if we can tabulate on basis of record of the species, then we see human observation are plenty, machine observation are even more. And this second function, this function here, or this code here, is basically filtering the records based on basis of record where we only have human observation, and preserved specimen. So that has not changed. This is just one of the columns in among these 164, which we can use to filter our data. So for now, I will just rerun it with the same. So the number of rows retained now is 3026. Remember, we only had this for human observation, and then we also added this observation and also preserved specimen. So 93 plus 1 plus this gives us 3026 records. Others like machine observation we left out. I mean, I'm just trying to reproduce what he did so that you see where the errors normally pop if you try to rerun the code without the latest, considering latest improvements in the version. So now I'm seeing, first of all, we are getting the error here that the function is, or the code R is not able to find an inherited method for the function select for signature data frame. This is because select is one of the functions that we also have it in other packages we already loaded. So for this data frame, there is no select function for it. So the select, which is currently active here, is expecting another data structure, which is not a data frame. So we will kind of force it to know that we are requiring the one from dplyr and not the default one. And that should run without an error. Then we can check the first 6 records, which is given by head of SPG. And now you see we have really selected just the latitude and longitude out of the 164 records we had before. Then we add a column called species because we want that dummy one value for each record because these are presence only. Actually, we could also filter by that, whether it's presence only or presence absence, but for now, we go with that. Then, because I loaded tidyr, we can use drop NA so that we drop the NA. So this is the same thing which was in his code. We have not changed anything. And now when we check the number of rows, there was one NA. Initially it was 3026, now it is 3025. So we dropped one NA, which is good for the next step because some of these functions do not, especially the coordinates function does not work if you have NA in one of your columns of latitude or longitude. So the class is still data frame, but if we pass it to this coordinates function and we check it, it becomes spatial points data frame. Now, personally, or in the current package, SDM package, it, first of all, when you load it, now that I loaded it more than once, it comes or it calls Terra package. And in Terra, we don't have spatial points data frame, but we have spat vector and spat raster. So for now, I will not go by this spatial points data frame. We will not proceed with it. We will change it to spat vector object, which is from Terra. So the only thing we change here is that we now don't do this where we use the SP package, but now we are going to use our SPG data frame and then we vect it. Or we can just say vect SPG because vect is from Terra package. And then what it expects here is geom, which columns form the geometry, just the way we provided for the coordinates function. And here we give longitude and latitude. Something to stress here is that if you interchange these, then the positions will not fall where you expect them to be. And then we also provide the coordinate reference system because sometimes we have the coordinate reference systems which are projected and not the geographic latitude, longitude. So for us, when we look at these coordinates, and probably all that records which are in GBIF are in EPSG 4326 or WGS 84. So we just provide that as the CRS. So just by this, we are now moving away from the coordinates function and we are creating a sparse vector. We provide the data frame with the latitude, longitude, and species column. Then we provide the geometry. We tell it that we need the longitude and latitude columns as the geoms. And then our CRS of the coordinates we have there is 4326. So this will give us a sparse vector object. If we now check it here, we see it is a sparse vector. It is not spatial points data frame because this its support in the current package is minimal. So you better go with the sparse vector. Now, when it comes to downloading bioclim data, which is the predictor variables, again, a lot has changed. We no longer go with this old raster package, but now we use geodata. So geodata already gave us the occurrence records using SP occurrence. And now geodata again is going to give us WorldClim data. So what we use is WorldClim global function so that we receive the WorldClim data for the whole globe. Then we provide these parameters. I think those are enough. The variable, we will need bio variable. The resolution we need at 10. That is the same as what we had here. The resolution is 10, the variable is bio, but here it was, you had to specify the source. Here we don't specify because it's already embedded in the function. So I will not put this in my computer, but permanently in my computer, but I will put it in a temporary directory. So I just say path is temporary directory. When I restart my computer, all of it will be gone. So when we do this, it just ran super fast now because I think I already downloaded it and I've not rerun my computer. So it was still in the temporary memory or directory. So if you want to save it in your computer, then you will provide the path. For example, C whatever or D whatever. But yeah, for me, I just want it in the temporary directory. Again, you can have it in temporary directory, but you will have it as bio here. So if you have it as bio, you can still write this bio out using write raster function. For me, that is not important now. Names bio still works because it's the same way we obtain names from a raster stack or a raster brick. We still use that for the sparse raster. And we see the bios, the names are given like WorldClim version 2.1, 10 minute, arc minute, and then bio 1, bio 2, bio 3. So these names we may need to clean them. Initially, they were just bio 1, bio 2, bio 3. But when we download it from using this function, the names are given with WorldClim. So if I want to rename it, then I can just say names of bio. I can use paste function so that I just write bio once. I don't say bio 1, bio 2, bio 3, bio 4, bio 5, up to 19. So if I run this without storing it into the object, you see that it's now bio 1, bio 2, bio 3, up to bio 19. I've paste with 0 so that the paste does not create space between bio and the numbers. So I can now run line 60 so that the names in bio are now converted to bio 1, 2, 3, 4. No big deal in that, but just to have names that are easier to read, or even when we are plotting, we don't have so long names. Cool. Then plot still works. because the plot now knows that the data is in um, spat raster, and we can plot it. Then points SPG works, but I would not wish to use points SPG. Rather, I would use plot again, SPG, and then add equals true. Set add to true. So this will still do the same thing. It still plots on top of that. But this works. Draw extent, if I run that, it still allows us to draw extent around this. Like you can click, sorry, you can click. I have to cancel that. Okay. So click here, click here. Okay. Somehow, no. Draw extent does not work with the Terra spat raster object in the background. Yeah, that's a good one to see and also to fumble a bit. Well, so what I'm going to do is the map edit, which I told you we installed. We loaded. Of course, for us to load it, you must have installed it. Then there is this function called draw features from map edit. Again, those who built map edit, big thank you to you. We can just pop map edit. Who are they? This team, yeah, great job you did. And yeah, we appreciate it. So with draw features, you can draw a map even more flexible than draw extent, as we will see. Because now it gives me this interface, which now looks almost like QGIS. I can zoom in, I can zoom out, and I have a lot of functionalities here. I can draw a feature, which is just a polygon. I can put so many coordinates around the area of interest, or I can just drag the extent the way I could do with the draw extent on a raster object. So for now, I will use this one. Of course, that will be different from what Babak did because he just used the draw extent to drag around. But I just want to add a little bit of interesting thing. Like these are things that we didn't know that we can do in R. We knew we could only do them for a long time in dedicated JS software. But now, thanks to that team, we can do it, and you click to the last point. Then you remember to click done down here. After that, now your E is an SF object, a simple feature object, which is a polygon. And with this polygon, you can now crop and do whatever you want. Normally, you would have your extent or region of interest as a country or something else, but for now, I'm just giving you a comparison of draw extent, which now can't work, with draw features, which works. We can crop directly. We don't need to convert E to spat vector object. Remember, it is an SF object, simple features. We don't need to convert it to spat vector. You can just use it the way it is to crop. Points, we can add points on top of what we created earlier. But again, as I said, I would rather prefer to use plot SPG color gets red and then add equals true. I would prefer the second option to the first option, although it works. Then we also crop our bio to bio C, and then we can plot one of them. We cropped, but we did not mask. So we still see the crop there. So let me add this function called mask is equal to true. Um, of course, we can just write letter T alone or TRUE for that. This adding mask here in the crop ensures that the anything outside E is left out. Okay, so now we see some cropping here, some masking done. Okay. Remember that if you want to leave out what is not included within the polygon, then you use mask. Okay, so comes the next step of multicollinearity check. Library USDM, we already loaded it here, if you remember the last one. No harm in reloading it. VIF remains the same. We can see the variable inflation factor of each of our 19 bioclimatic variables. And then he extracted only for the region of interest for the occurrence records to do the exclusion. I will not use raster here, but I will use Terra because I think if we use raster, it will not work. Oh, it works surprisingly because this is a spat raster and this is also a spat vector. But they are so aligned that the whatever extract functionality behind them is the same. But just for better alignment with the Terra, I will use the Terra version of it. So I will change this to Terra extract. That will also work. And then we can check the X, the head. The head will be with the ID of each record and then the value for that particular location, the value of all predictor variables that were used. Yeah. Not really that were used, but for all of them, because this is when we are going for the exclusion in the VIF step. Now, another point here to mention is that inside here, there normally people just say VIF step, then they provide the predictor variables. Of course, you can provide the extracted or you can provide all the predictor variables. The choice is yours. And you can set the threshold for VIF step. It's normally the default is 10. For VIF core, this one here, the threshold default, I think is 0.9. Let me check. VIF core. Yeah, it's 0.9 and VIF step is 10. One nice thing that Babak and the team has added is this function here called keep. And inside this keep, you now have the freedom to say which of the variables inside BioC are important to the species of interest, such that whether they are correlated with any other variable, you still want them to feature in your model. So you can force to retain them by saying keep the following variables, maybe bio2 and maybe bio6, if these are variables that are important for your species. So this is a new thing which I think is so nice, because normally we say you just exclude the variables that are highly correlated, but sometimes ecologically they are important for your species. So for now, we'll just run the VIS step with the default threshold and no special variable to keep. Then we will use the exclude function. This is also coming from USDM package, and it just excludes everything which is highly correlated from the group. So here it says 10 variables from the 19 input variables have collinearity problem. So those 10 are going to be excluded in this step. Now, if we look at BioC, we should see just 9 variables because 10 had multicollinearity problem and we did not force any to be kept. So those that were highly correlated were dropped. Then we come to building of the SDM data object. The species here is the species column in the SPG spat vector object. If you look at SPG, you see that there is a column called species, which has 1 to 1, 1, 1, 1, all the way, dummy 1. Then predictors are the BioC, which is after excluding the highly correlated one. Then BG gives us the random predictor variables from within the extents of BioC. Again, here I wish to highlight that the team has worked hard to create a function called background. And this background function helps us to generate these records in the background. It has got arguments like X, and this X is the spat raster with the explanatory variables. So for our case, it's the BioC. Yeah. And then after BioC, then we provide N, like how many points do you want, background points do you want to generate? And then there is the option for method, where you can provide one of the several, like we have edist, we have gdist, we have erandom, we have grandom, and I really invite you to go to this background function using the help, the question mark help handle, and then you will be able to see all these arguments which you can put there: erandom, grandom, edist, gdist, and even bias file, right? Yeah, you can also provide bias file because normally we say sometimes we say we want records to be picked far away from the presence points or far away in terms of the environmental values, values in the environmental variables. So we are free to also provide that bias file. This is something super important, and I wish probably one day they will also provide uh, an a parameter or an argument for region of interest specified by the user, so that if you have your own distance, or not really distance, but a bounding box somewhere where you want the background points to be picked, of course that must fall within BioC, then you just provide that shapefile here. I've done it manually somehow. I had my own background region of interest, and I've manipulated the function to ensure that it just picks within that. But this, I think, is something which can be incorporated here. I mean, so that you decide, because edist will try to move to pick points far away from, as far away from the distributions of the presence points. Same to edist, far away. So, and the grandom and erandom are not the best you want to pick. So you should be able to provide your own region of interest from which to sample. Of course, that region of interest, first of all, must fall within the BioC, because this is where the values are to be extracted by those points. For now, we will just run it the way it is. Of course, grandom is still intact, so it will still run. D here will still give us the uh, records as we expected. Then there is this get methods names. I think that is still okay because it still tells us, it still enables us to pick background, not really background, but the method we want to use to run our data. Remember in SDM, you have that freedom. That's one difference from other packages. You have the freedom to pick which machine learning method you want to apply, you want to use for your modeling. And you have so many methods. You have BioClim, Dismo, BRT, CAT, GAM, GLM, MLAP, RBF, RF, RPAT, SVM. And you are also free to add your own using the add function if you have. Not all packages which are used to model species distribution out there have that freedom. Some are so confined that you can only use, for example, BioClim and Maxent. Others are Maxent only, and so forth. But here you have the freedom to use, for example, if we checked the length, not really the length, but nrow. If we check the nrow of get method names, we see that there are 22 of them. Okay, so here Babak just used 4 of them, and replication methods, subsampling and bootstrapping. Sorry. And then test percentage of that and number of cores. 10. He used 4, but I've just set this to 10. He also said that he wished he could add a method here, a function here, or a name here for all, which allows you to use all methods if you want. Now, that is not yet done, but so if you want to do that, one way I got, which I think somebody can apply, is just to say get method names and then $ methods. That will give you a vector of all the species. I mean, of course, Babak knows this and his team, that get method names returns a data frame. It returns a data frame. So if we check the class of this output, it is a data frame. And in a data frame, we have columns. So for example, if we were to store this into an object, say B, then this B, if we put a $, we see it has the names and it has the aliases, like it's also called. Same method can be called by different aliases or different names. So if we just extract this, then we get the all the 22, a vector of 22 characters. So if you want to use all methods, before the all function is provided, you can just say get method names, and then outside there you put $, and then you write methods. This returns a vector of all methods, and methods here takes a vector of characters. If there is a method you don't want to include, then you just provide the name or the index of it. Or if you just want to use number 1 to number 5, you can do that. Or you can still provide a vector of the ones you want to use, 1 to 3, then 7, 12, depending on how much you know about the alignment, like which is number 1, which is number 2, which is, then you just provide like that instead of providing their full names. I hope that is clear. I don't want to run all of them now because that will take long, but let me just run it so that you see there is no error. So by this alone, you can tell that something is running in the background like all methods are being run, but I don't want to run all of them now. So let me try to go back until we get what Babak used. Okay, I think minus all, they were 4. Okay, so we can just run the 4. This will also take some time, but as it takes its sweet time, I think it is also good time to go back to this E-random and G-random and E-dist and G-dist. Specifically G-dist and E-dist. G-dist will randomly pick background points within the extent of your predictor variables, but it gives more weight to locations with larger distance to species presence locations, which means areas that are very far away from the presence will be more likely to be sampled. So be careful with this, especially if your region of interest is so big, because you might be obtaining background points from regions that the species will never ever reach. For example, you are mapping lions in Serengeti, Tanzania. Then you have the whole world as your region of interest. Regions that are very far from Serengeti will be more likely to be picked as background points. So you can imagine background points being picked in Antarctica or in Greenland. Chances of lions going there is very minimal. And therefore, we don't want to include those ones for obvious reasons, that the species, is way beyond the species range. When it comes to EDIST, again, it randomly samples within the environmental space. That is, it looks at the values of the environmental variables. Then, again, but gives more weight to locations with environmental conditions that are more dissimilar to the locations where the species are observed. So here again calls for another care, because just as with the EDIST, locations that are in Antarctica will be favored for my lion mapping in Serengeti. So again, when mapping a species, try to ensure that the region of interest is not too far away from uh, the region where your species is distributed. And this is why I was saying we might need an argument to allow for the users to provide some shapefile or bounding box or something like that within which they want the sampling to take place. Maybe they don't want the sampling. For example, with the Serengeti case, maybe you want just the points to come from Tanzania, Uganda, Kenya, and maybe parts of Somalia and maybe Mozambique. You don't want your background points to stretch to, say, Morocco or to stretch to, say, Lesotho. So, yeah, instead of course, this, when having your biopsy, already you've normally cropped it to the region of interest. If that is the case, you are safe. But if that is not the case, then I think we might need to rethink or to include it, should be included, the region of interest. Cool. So our model is done. If we check M, we have our output. Basically, not much has changed on this output. Um, not really the actual values of AUC or TSS or whatever, but that the same way the structure of the output we used to see before. And inside this model, M, there are a lot of things that you can extract. And from these slots like setting, run info, and all those, just the same way as he highlighted here, but we will not get into that for now. Graphical user interface remains the same. You can still explore a lot of things here. The model evaluation metrics, all these are still visible, threshold based on the rest. He went ahead and made a prediction, so this still works. We can still predict. Now what we are doing basically is to apply the model we've trained, given the background and the presence points. We are now applying it throughout our study area to see where else they are suitable for the species. Well, that has finished. So we can see the P1 is 24. They are 24 because we have 4 methods being run by two replication methods. So 4 times 2 is 8, and each one being run 3 times. So this is 2, this is 4, 2 times 4 is 8, and 8 times 3 is 24. So in the end, we had 24 methods. Now, when we use predict, then each method has its own output. And if we check that with the names in the P1, you see that it picks the ID, the species. If you have several species, they will be listed. And then the method, GLM, and then subsampling 3 times, bootstrapping 3 times. Then it goes to the next method, BRT, and a subsampling and a bootstrapping 3 times. If you set n to 10, if you set n to 100, then you will be having 100 times 2 times 4, which is, 800 models successfully trained. We can visualize them the same way because this is now a sparse raster object, and we can still index them like this to obtain some maps. And in each map, you can see whether it's a GLM and under subsampling replication, whether it's a BRT subsampling, RF subsampling, RE bootstrapping, depending on which method or model run you are picking. For ensemble, again, not much has changed. We can still run ensemble by weighting. So the difference with the predict is that in ensemble, we are now allowing for good performers to help to outweigh the poor performing methods in final model output. Many people have been asking, how can I see the AUC or TSS or evaluation metrics of my ensemble model? So when we are ensembling, we are calling upon each method which was successfully run to contribute in the final map. And in their contribution, you decide on which metric you want them to contribute by. If you remember, for example, let me just give this as an example. For example, here we have GLM 0.65, BRT 79, RF 92, and FDA second last 66 or 0.66. So if we use TSS as the evaluation metrics to ensemble our methods, these 4 methods, then largely our output will be as a result of the RF method. So RF will have high chances of will contribute highly to the final ensemble output. And it will be followed by BRT because we want them to contribute, but we give good performers more weights. Poor performers like GLM will receive less weight, which means it will not contribute much to the final ensemble output. So our final ensemble output has no AUC or TSS of its own because it's it's a coalition, but it's a coalition based on strength of uh, the evaluation metrics we decide on. And then we also provide the optimization parameter. For now, I will not run this. I think Babak also did not run that, but he ran the one with the prediction. Like you can directly provide the output of prediction here and then rerun the same. So I will run this. Different file name. Okay, that's also an interesting thing to know because I changed the names somehow. Yeah, I remember. I changed the names. So there's an interesting error. What does it say? The specified file name does not exist. You may use overwrite or use a different file name. Okay. Then that's to do with this. Let me give it a 2. Yeah. Oh, okay. Then it's not what I thought. Um, Good thing to read the error. So when it told me you may use overwrite or what is, then I just realized that, okay, then it means whatever I'm trying to write out is already existing. Well, so it ran so fast because I think I had already done it before. And of course, it's because we already made the prediction. If we had not made the prediction and we were using the bio, then under the hood, Ensemble is doing the prediction first and then checking the output based on TSS or evaluation metrics we want. Enough for that. So we can plot the final Ensemble output. Now, a little bit on this again. This map here is as a result, let me replot it so that we see the legend. It's as a result of combined contribution of all the methods, the 4 methods here. But it was largely contributed by RF and least by GLM because we used the TSS, and in TSS, uh, we used TSS, true skill statistic, and in that, RF had higher weights, and we said the method here is weighted. Again, you can check ensemble. It is one method that I have explored quite a lot. You can check ensemble to see other settings you can provide. Yeah, like start, expression, you can provide the IDs of the methods you want to run. If you don't want to ensemble everything, for example, in our case, GLM performed quite poorly. If we look at M, GLM performed poorly. Oh, that's FDA. Where is GLM? GLM is here. So you might decide to drop GLM. So all the model IDs corresponding to GLM, you don't include them. So you can provide the ID argument. Okay. Now we move to the future. For the future layer, I will not use this. For example, if I try to run this, it will throw me an error, I'm sure. It's throwing me an error, and it is even pleading with me that please use the geodata package instead. Get data has been removed. You see, it has been removed. So if you watch Babak's video in 2020, you can say he ran it and it worked. But now I'm trying and it is throwing an error. It's not working. Those are the kinds of comments that we normally receive, that mine is not working. So why is yours not working? It's not working because this function has been removed. And when you run it, it tells you to please, it pleads with you, use geodata package instead. Okay, so let's use geodata. For geodata, let me just use it in full. We are going to use CMIP 6 world. Okay, that is CMIP 6 underscore world. There are a lot, there is CMIP tile if we just want for a small region, not the whole world. And it can save you a lot in case of downloading for the whole world is a bit of a problem. So here we provide the model. We provide the shared socioeconomic pathway of interest. We provide the time we want. We provide the variable we want. We provide the resolution we want it to be in and where we want to store the output. These are basically the same things that Babak was doing here. Like he provided the model, he provided the variable, he provided the resolution, the RCP, representative concentration pathway, which is now the SSP, which we'll now call here the SSP, and then the model and the year. Well, in CMIP or CMIP world, if we run the question, we will see which methods are available and which times are available. So, for example, in our case, we are going to pick hard game. I don't know why. I like hard game. Maybe it's not the best, but okay. He used BC. So which BC is that now? Maybe this. So let's use this. That's the model. Sorry. Then shared socioeconomic pathway, use the worst case. So that is 585. And these words here are very important. Character, 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 numeric. Character, 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 numeric. So it tells you what you put in, whether it's a character. And if it's a character, you put it in quotation marks. So the SSP we are going to use is a character. So first of all, quotation marks for it to be a character, and then 585. Initially, it was just 85 as numeric, but now it has to be provided as a character. Time is character, and we have this and that. So which one is close to that? Probably 2061, 2080. That's where 70 falls, because that was, I think, 2070. Then variable character, T-min, it's a character. So again, quotation marks. And then bio C. Here it was just bio, but now they're saying it is bio C. So we just respect that. Resolution is numeric, so we don't put quotation marks. It's a number. And he used 10. We are just going to use the same 10. Path again, he did not use any path by then, but now if we try to run this without path, it will throw an error. So let me run that. Error, path missing. Yeah. That's good to help you so that whenever you download it, you know where you want to save it. For me, again, I will use temporary directory because I don't want to fill the memory of my computer. I think already I ran this and it threw an error and it pleaded with us. But this one now, if I run it, it will run without an error. Wow. This is the worst case scenario. This is the worst case scenario, which I dreaded. That sometimes your server seems to be temporarily out of service, and you will see this quite a lot. So whenever you see this, don't panic. Again, of course, whenever this happens, it means you can also not go to WorldClim directly and download it. Let's try that. If we now go to worldclim.org, and try to download future climate, uh, future climate, CMIP 6, 10 minutes, 2061, 2080, and BCC this one, BCC under the worst case scenario bioclimatic. Yeah, here again it says not found because geodata function we are using is also referring to this same site. Now, something which I've found to help, or a platform which I've found to help is called Chelsea. So I just go to Chelsea, downloads, and then global Chelsea download. Thank you again for those who are behind Chelsea. I go to climatologies and then to 2070. For now, let's pick this. It may not be the best that coincides with it. And again, now we are going to choose just a different climate, GCM. In Chelsea, we have only 5 of them, 1, 2, 3, 4, 5, as opposed to World Clim, where they are around 18, 19, or 20. SSP 585, then bioclimatic variables, and then I'm going to download. Of course, it starts with Bio 10, probably because of ordering numbers somehow. I'm going to download all of them. Or I can just download the ones that we retained for modeling. The ones that we used in building the model. There is no need of wasting time downloading everything yet. We didn't use them. So let me see what we have in BioC. Names in BioC. So we have Bio 238. Let me start from Bio 10. We don't have Bio 10, 13, 14, 15. 13, 14, 15. Not 16, not 17, but 18 and 19. 18, 19. Okay, in terms of 1, we have only 2, 3, 8, 9. We have only 2, 3, not 4, but 8 and 9. Yeah, so those are 10. They are more than what we had. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 2, 3. Oh, 1 is still checked. So now there are 9. That's good. Then we download this. This is just a file. It's just a text file. It's just a text file in. Yeah, it's just a text file which has gone to my download folder here. So I can loop through this to download the data and save them in my working directory. Wait a minute. Or I can just download them directly. That will be probably even easier or faster. Of course, looping will be easier. I think so. But let me just download them and save them directly to my working directory. Yeah, the people behind Geodata, yeah, you are doing great job. Unfortunately, for now, we were not able to get one of the bioclimatic variables we were looking for the future, For the current, it worked. For species records, it worked. Uh, but for the future, um, it failed. It said temporarily out of service or something of that sort. Yeah, sometimes it does like this. It's not a problem. It's just about limiting the number of downloads you can run at the same time. So if this number changes to 5 or something, then it will just allow me to proceed. Uh-huh. Again, looping through would be easier. I will not be wondering which one did I download and which one have I not downloaded. So it will be easier. If you have that get file, then you just read lines and uh, loop through to download and save. I'm not doing that because it will involve creating another function to do that, but that will take us much time, like a function to loop through the lines and read each and then paste and save into the working directory. Yeah, would kind of take us some time. Which one has been successfully downloaded? This one, where did it go? Okay, it's in my downloads. So I can collect them from there once it's done. So I even don't need this for now. Let me just wait for the rest to get downloaded. And then we lift them from here to, oh, now I have no option but to use my working directory. So I can take that few seconds to go to my directory, tutorial here, and then add another folder for data. Yeah, so that, oh, I've just placed it inside the script folder, which is not one of my best practices. I'll just put it here. So it's in the tutorial and then it has its own folder. Hmm. Hmm. Taking a bit of time, but should be done not so long from now. Again, some of the challenges that you might face when working with these kinds of data. One, you don't have to panic. Just read the error, then alternative. Again, I didn't check. Probably if we tried another uh, GCM, another one of this, which is not this, probably it would have downloaded, not BCC. If we, I was so inclined into hard game. Let me see if this can work. Interesting, the world we are living in. So hard game works, but um, the BCC, where was it? BCC. This BCC failed, but hard game uh, got downloaded. Interesting. So we can proceed with what we have and forget about the other one. So again, sometimes one model can have the data you can get easily like this. So sometimes you might try more than one. We've taken too much time on that. Let's see. Um, Yeah, and the arrangement is nice all the way from bio 1 up to the end, and they are 19 in number. So we may need to rename them. First of all, we check the names. Okay, let's plot one of them just the same way Babak did. Hmm. That was just error due to margin, not a big issue. Can do like this. Some warning, but not a big problem. Names of BioF, you can see these are now bio with 0, 1, but like leading 0. In my case, I didn't have them. So, oh yeah, so you also renamed them in terms of names of bio. So let's check our names of bio just to confirm. They are 1 to 19 for sure. So we want these names to be here. So what we do is just to say names of bio F takes the names from bio. It's the same way if we used like paste 0, bio in quotes, then comma, then 1 to 19. Okay, so directly for the future, we don't build model again. We already had our model, so we only provide the future layers and then uh, ENF. Maybe I also add 2 for this. You can make prediction or you can make ensemble like this. But I think this is going to fail. Let me try. Hmm. Seems it's not failing. The reason why I thought it was going to fail is because this model we trained on a subset of predictor variables, not everything in bio, but everything in bio C. So since bio F has more predictor variables than bio, no, than what we used in training the model, which was bio C, then I think it was going to say some of the names, some of the required variables are missing. Oh, okay. So in this case, all the variables are here plus what it doesn't want. So it just picks what it wants inside this and uses them to build the model. Interesting. So it only throws an error if you have less variables here or different names here than in the M. Hmm. Oh yeah, nice to know. I don't know whether it would be nice to ensure that even if provided they're different, or even if it has more than what are here, it should throw an error, or only if it's in the model but it's missing here. So you can have a million variables here, but the model will only pick what it was used to, what it was trained on, and then discard the rest because it can't make prediction on what it was not trained on. Interesting. That's taking a bit of time. Remember, we are now making this prediction for the whole world, and we are not using predict first. So the ensemble model is doing the prediction on all the 9 variables. And then after making prediction, it then goes to each model based on their TSS with optimization parameter set to 2, which is maximizes the TSS, sensitivity and specificity. Then that's when it finally ends up with the final model, which is EN2. Not model, but map. So this is how the final map looks like. And Babak provided some color range for this, created a color and palette using those colors, and then plotted EN1 with that set to 2, then plotted the second one with a CL set to 200. So again, looks like that, no problem. Map view, he tried this. I think it threw an error, and then he said you need to separate them. If you want to add more than one layer, you just put them separately. You don't stack them. In fact, stack cannot work here in the first place because these are raster files, I think. Can we stack spat raster? No, we cannot stack them. So this does not work. Better comment it out. But if we just check for one that works, you can view one. The error you are likely to see here is a warning, probably about CRS or about the number of pixels, the maximum number of pixels, but not a big deal. And then the change between current and future. This again might throw an error. Yeah, because now the extents do not match. Remember my EN1, if you look at them in the plots, this is the EN2 for the whole world, and this is the EN1. The original prediction was only for a small area. So I might need to crop my EN2 to the extent of original E and even set mask equals true before I subtract N1 from it. If I do that, it will work. But if I don't do that, then I'm using for the whole world. So this CH is just this extent. So I can crop my EN2, which is for the whole world, to that extent and mask everything outside it. Again, we create a new color palette for that, and we can visualize it. All right. Again, it's up to you to look whether it's necessary to subtract probabilities, whether it's statistically correct to subtract probabilities, because these are probabilities of occurrence that we had here, same to what we have here. Are we statistically, are you statistically okay to subtract probabilities or to multiply? I think multiplication is okay if you expect two things to occur at the same time, but subtracting them and saying, yeah, maybe correct, maybe not so right, but you might need to dig into it and defend. What I would do is to binarize it first, change them to binaries. For example, given a threshold, and then with that threshold, I can, after getting the binaries, I can manipulate the zeros and ones better than the probabilities. Again, converting the D object to data frame, I think this was now the evaluation to evaluate the model. This will work. You still can convert the original D object, which we created, which was the SDM data object. We can still convert this to a data frame using as.dataframe to CDF. And we can check the head of DF, which is basically containing the species column and the predictor variables corresponding to each of those records. And then he created a data frame which contains the species column, and the species column he obtained from the DF, which is here. And I showed you the species column in that DF already. This column here with all ones. By the way, remember at the bottom, it has some zeros because we added background. So if we check tail of DF, then we are likely to see under the species column, we'll be seeing zeros. These are what were obtained from the background. Although if we check head, we see ones. We see species column having ones, but at the bottom, there are zeros. So this contains the ones and zeros all through. And then coordinates of D I think coordinates will still work here. Coordinates of D. No. Wow. I'm happy for that. That coordinates no longer extract coordinates from D. This has changed. So let me enter this and put a hashtag to that and say that this is now chords. We can now use chords to obtain coordinates from D object. We can no longer use coordinates. I'm glad it's changed. So in the end, in the DF, we now have species and we have the X and Y coordinates of where that species record was observed. So he converted it to matrix. Again, now we don't have lon and lat. That one was only brought by coordinates function. Now we have X and Y. So those are what we use to create the matrix. If we check the head, it is just X and Y. And then P, we can still use extract to extract from EN using this EN1, which was the first ensemble for XY. Remember, this extract could be coming from raster, but if we provide Terra function here, it should work as fine. And if we look the head of P, these are now the extracted values corresponding to each of these pixels. If we look the tail of P, we expect those values to be a bit low because those are where we had the zeros. So these values are generally lower than these ones where we have the ones. We had the ones. Anyway, number of rows in DF is 3857, should be the same as the length of P. No. P, head of P, end of DF, length of DF. Okay, because now the extract here is returning a data frame and not a vector, then it gives the length of one because we only have one column. We can use $ and put ensemble. This has changed from original one. And now we have the vector spread out, or you can use pull function. You can pull a column to a vector. So we can add that somewhere. Length of P, that one no longer works. Or it works, but it only returns the what we don't expect. So we put this to to spread the values as a vector like this. So the length of P now, if we now check the length of P, it should be the same as the number of rows in the data frame. Evaluates is now DF species, and then we are extracting EN1 using DF. Wait a minute. What about the head of DF? Okay, we still have the species column. I would say here we don't need this, but we need P. So we can just put P directly. And for this, we need this DF. So that should work. And again, in EV, we have a number of things. We have threshold-based statistics. We have predicted and observed. Those have been there before. And what happened here was that he just picked the statistics. Not really the statistics, but the threshold-based. So he went to EV, picked the threshold-based. Let me put it here. EV threshold-based is number one. And then $, we go to threshold. And then the threshold that maximizes sensitivity and specificity is this, the second one. So that's why he picks this. If we just run EV and then threshold based like that, you will see a number of values. So the one which he picked, which is this, is the same as the value here because it's the threshold that maximizes sensitivity and specificity. That is, it account for over prediction kind of and under prediction in loose terms. So that becomes the threshold, and that threshold is what we will use to binarize this. Again, here we can create, he created a PA object using raster of EN1. So this will be a raster with the same dimensions, resolution, and everything as EN1. I think for me, I would even put this direct to EN1 without using raster, just to comment out what doesn't work. And then say PA1 gets EN1, just like that, because it's the same thing for that. And then this function here does not change because it's if-else function and everything is being fed from EN1, whatever. If the value in EN1 is greater than threshold, then give it a 1. Otherwise, give it as a 0 because that's the threshold. I think this is one region where people normally have problems. How do we binarize our data from suitability or, probabilities? So you just say you want to give the values, you want to fill the pixel values here using a value of 1 if the value in the EN1 is greater than the threshold, otherwise give it a 0. This is not the only way. You can use so many ways to fill in values of this new raster using these values. Too large, margins too large. That's not an error of SDM, but this region was a bit small. So if I do that, I just see the presence and absence map, the binary map. Then for the future, he used this. So again, I'll comment that out and then just create a PA2 and give it an EN2, sorry. I mean, EN1 and EN2, they are just basically the same extent and resolution. Again, if else, EN1 is greater than the threshold. The threshold does not change for the present and the future. We use the same threshold for we trained the model. The model has, the model we are using has. And then we can, again, see what happens into the future. Of course, for the future, we have the whole globe. I've not cropped it. I only cropped what I had predicted out. Change in probability, then we will have to crop this again. I wish I had cropped it earlier, but I can still crop this using E, and then mask is true, and then close it. Then we can plot this. I mean, now I'm comfortable doing this subtraction because these are now binarized values. So there is increase, decrease, and that. Then we can plot that and we can plot it with beta colors. Apparently, we can consider those as beta colors. Negative red, uh, uh, not really extinction, but reduction or loss in suitability. 0 remain the same and 1 are gains. So there is gain towards the Drakensberg, Southern Africa. Anyway, here I would do it. First of all, there is now a new function which doesn't require you to do all this math. The new function, I think I should put it at the bottom. There is a new function which is called PA. And this PA is from SDM package. Yeah. So with PA, you provide X. And X here is a sparse raster object, which contains the probability of occurrence. So in our case, our PA would be EN2. Let me use EN1 for now. Let me plot EN1 just for you to remember that what is this EN1? This probability, suitability, or yeah. Then after that, you provide Y. Y is the SDM models, which is M in our case. ID, if you want specific models, yeah. Otherwise, you can just use ensemble, the word ensemble. Optimization parameter, the default is 2, so that is what we will go by. Imagine this group have made so much effort that all this, not all that, but from here, all this math, in fact, the math started up here with converting things to matrix and all that, to data frame, to matrix and all that. They have simplified it into just PA function. So I don't know how best I could name it, but maybe simplified would do for now. So if we run this, we are saved of all the worries of which matrix, which threshold, which what, all this that we have just simplified it here. And this simplified, if we plot simplified, oh, sorry, it should basically be the same as the plot of PA1. Slightly different just because of not really the decimal values, but the threshold we get here, I think it's basically the decimal. Let me see, is this, but the threshold we get here, I think there was a time I calculated them manually and compared with what we have. For example, this is 79658. If we look at GUI M, could be decimal thing, but let me just confirm that. Evaluation threshold based, and then we look for it here. Yeah, it's 0.76. So 0.76 compared with 0.79, a small discrepancy, but not so much. Of course, if you move this around, you see that there is some area changes. Again, probably something I'm missing, but it will be interesting to know if somebody spots out why that behaves that way in the comment. Anyway, additional things that Babak suggested, we are almost through, is to check the response curves. I think those basically remained the same. So R curves, oh, that's going to take this some time because there are like 9 of them. I mean, response curves are very, very important because they are what tells you whether you've really exhausted the niche, whatever defines the niche of that species, the bioclimatic variables or then environmental variables that define the niche of your species of interest. If the response curve is not unimodal, like it doesn't start somewhere down, increases, and then decreases at some point, then you've not exhausted the nature of your species. Otherwise, or your species is disobeying the niche theory. Like it increases, then it falls, it again increases, it falls, it increases, it falls. It's a rare phenomenon. It's not a good sign that your model fully captured the niche of your species. And niche theory is what all this is based on, same as niche conservatism theory hypothesis. You can search. I mean, it will be interesting for you to search on your own what niche theory entails. So this is nice. It increases and then it drops, increases, drops, increases, drops, increases, drops, and flattens at some point, increases and stops at some point, increases, drops, increases, drops, increases, drop. Okay, something that could be funny would be this bio 9. Like it increases, it fell a bit, and then it increases, then it forever dropped. We normally want a unimodal curve. So for this species, apparently we did some good job in that, in capturing the full range of its environmental variables, each of these environmental variables. Again, if you're plotting R curve, you can provide the ID of the names of the methods of the predictor variables you want to uh, run. And again, you can also provide the R curve of the ID of the methods. Okay, then let me provide for name. He did not provide this, but I can just provide it now, maybe bio 9, which we are questioning. That should be faster than when it was running for all the bios. If you just say N is bio 9, it means the name of the bioclimatic variable you want to plot its niche. I expected that to run faster than it's taking. Yeah, as it runs again, remember two things, niche theory and niche conservatism hypothesis. Otherwise, we could not make projections beyond the area of where the species has been observed. We cannot make any prediction beyond that if the species cannot hold on to the traits that made it fit for its occurrence point. If it cannot hold beneficial traits that helps it survive in a given environmental conditions, then we cannot claim to make predictions beyond that location. Yeah, so this not too bad. The dent was not too bad, but yeah. So if you want to plot for one's response variable, you just use that. ID, again, you can provide the IDs of the methods you want to run their models. No need to get into that. You can get variable importance, provide the ID of the variable importance of the model you want to method you want to check its successfully run method that you want to check its response curve. Remember they were 24, so number 24 we can check, but number 25 will give us an error because we only had 24. 1 to 24. So you can provide 1 to 24 and you can plot it to see which predictor variables were important, more important, and which ones were the least important for your species of interest, and whether that makes biological or ecological sense. You can specify just for one method. What about random forest? What did random forest say? Did it agree with the others or did it say something different? You just provide the name. Something which I think was throwing an error, would be interesting to see what it does now, is niche. First of all, let me confirm whether these two bios are there in bio C, what was used. I can check that with the names of bio C. Do we have bio 18 and bio 3? Yes, which means we can check the niche. I don't know whether this has been corrected, so I'm waiting to see something strange. If there is nothing strange, then it has been corrected in this version of SDM. Mhm. Just to say what niche does, niche, for those who may not know, is just to compare, not really to compare, but to plot. It's a bivariate plot of two predictor variables. Normally, you pick the most important variables, most and the second most important variable. For example, we would have picked bio 9 and bio 18 for random forest, but maybe for the former where we had everything, we could have picked again bio 9, I think, and another bio. Um, Hopefully, I mean, it's taking some time because niche is still running in the background, and I'm also asking it to show me the previous plot. So we can just wait patiently. But what it does is to check the niche or the combination of these two variables, at which combination or at what values of bio 3 and at what values of bio 18 does this species feel more comfortable, in loose terms, not by academic terms. Um, for example, when temperature is what degrees and when rainfall is how many millimeters, does it fit? Does it find the niche to be suitable for it, more suitable for it? Uh, so it's bivariate. When we see the response curve, they are univariate. It's just one predictor variable against response. But when we do two um, variables, then we can see uh, how each of these, the combination of these fit the niche of the species. We can make three variables or four, but as we increase the dimensions, you remember representing it visually becomes very difficult, because how will we rotate if we have 5 dimensions interactively here to be able to understand the X, Y, Z, or A, B, C, D axis uh, in the plotting window becomes uh, difficult. So currently they support this bivariate. I'm not sure whether the team by um, Marlon Cobos and Town Peterson in uh, Kansas, at Kansas University, were working on a way of representing some more dimensions. Like here we have bivariate, but I think they were doing some kind of n dimension hypervolume of this, probably up to 3 or 4, maybe 3 or so variables. So you could see something like an ellipse or something like that with more dimensions added. I mean, not very sure. Somebody can confirm or check. But yeah, there was such a thing. I think I heard about it during one of the ENM 2020 training 5 years ago or so, 4 years and some months. This niche is taking some time because remember, it's spreading all the predictor variables and also the response suitability for the species, and it does so for two predictor variables. I don't know whether in the niche function you can provide the maximum number of pixels to use. Let's see. Again, this does not work. I mean, it's at such a point that R Studio can crash when I'm trying to ask many things and whatever. So in case it crashes, then we'll just stop there. Um, Basically, nothing much additional, but to emphasize that there is this new background function which can help you pick background. Probably they will also add, it will also be added the replication method, like people are really into spatial block, cross validation, checkerboard. If you look at the works by Jimmy Cass, I think so. ENM eval, vignette. They are working tirelessly in this uh, blocking spatial block method to partition uh, data into training and testing cross validation. So one quadrant or something like that is held out for testing, and the other quadrants are used for training. Not only block, but there is also checkerboard. So something like that, or checkerboard 2, checkerboard 1. And yeah, these are probably more robust methods, I think, to subdivide your data. But again, remember, you can also do this and then bring your already partitioned data and loop through them in your training and testing within SDM package. So if you want, you can borrow from there and come back here, especially if you go there. And what they offer, I think currently they only support BioClim and BioClim and Maxent and MaxNet. A few algorithms, not 20 or 22. Let me see, BioClim. No. Of course, Maxent, they support Maxent and MaxNet. Why did I think that they support BioClim? You can check it if you wish to. But I know they support, yeah, something like this. So if somebody could just buffer themselves, provide themselves a bounding box, which I was talking about, region of interest to obtain the background from without necessarily obtaining it throughout your study area. Especially if the bounding, if you are, the region you want to pick the background points is less than the full extent of your predictor variables. Yeah, not sure whether BioClim and, oh, not BioClim, I think it's called BioMod. Just mod. Oh, BioMod. Okay. Then maybe it's not there. Or it's there, but I couldn't find it. This has taken longer than I expected. And maybe the thing I can do is to use a smaller area. So allow me to stop this, or is there anything in the plots? Nothing. Allow me to stop this using the escape key, or I could just click here. I think it will tell me it's running and whether I wait or stop or something. Because what I want to do is just to crop both of these layers. Do you want to terminate? I don't want to terminate now. In the hope that it will just stop as I requested. So what I said I wanted to do was, okay, BioC is already cropped. So we can just use nature of BioC and then crop of EN1. Okay. So we can talk of EN1 cropped, which is crop of EN1 using E, and again mask equals true. Then we use EN1C for the niche. Let me try to stop it again. It's still not stopping, but it's not using even a lot of memory. Yeah, maybe it's also time to mention that area of applicability is another function that has been added to SDM function. Yeah, good. That's good. It's stopped, so we can crop this and then now try with the cropped version, which is smaller area. Yeah. So I think when I was doing it for the whole world, it was too much. But when we use now BioC, not Bio, and EN1C, which is just the crop of this, it's lightning speed. Now, what I want to point out here is that niche function still does not support sparse raster. And you can see the figures on the y-axis and x-axis are just concentrated in this top bottom left corner. They have not spread out like this. So a way out of this is to use raster function. I really don't like that. And I hope it will be resolved to work well with Terra-based, because these are sparse raster object. Niche for signature X raster layer, H is equal to raster layer. What did I do wrong? Raster stack. Yeah, because BioC is not one layer. BioC is 19 layers, 9 layers. It's only EN1C, which is one layer. So if there are many layers, we can just use raster, but we stack them from, I mean, these are things that I really don't want to see in my code, but for now, I just have to use them because that is what is still supported to provide the values on the X and the Y axis for the predictor variables. Otherwise, it would be something like this. If you use just Terra-based things, layers, then the values are not spread out on the y-axis. They're all concentrated in one small corner. But if you use raster-based layers, then a niche works well with them. Now, area of applicability is another interesting function which is in SDM. So if you use SDM and you query it, whether it measures whether the value of the pixel in sparse object X with environmental layers used to train SDM are within the range of variables contributed in the modeling. So this is also one thing that one should be keen to pay attention to, because sometimes we build model under one time frame and then use this model to make predictions into the future or a different space. Sometimes the environmental variables there are completely different from environmental variables from where the model was trained, and the model may not be able to make good predictions over there. So it's important to generate this area of applicability map because it will tell you how similar or dissimilar, let me call it AOAP, area of applicability, and then X is the sparse object with predictors used in SDMs. So our X is BioC. Sorry. Did I get it right? Sparse object, yeah. BioC. And then D is the SDM data or SDM models. So we can just put the D because it can take any. this is optional, numeric vector of variable importance values of the variables. So we will just leave it like that. So if we run this, our AOP is a sparse raster object, and it shows us which areas are similar to where the model was trained. So where you see 1, those are areas that are quite similar to where the values we used to train the model were, and areas that are less than 1. Here, most of them are same as 1. So here we can just build the model and make predictions. If we have a different bio, for example, I think bio F again was not cropped, so it might take some time to run this. But what basically is happening, I think it's bio F where it's even important now for us to check whether it's the right area of applicability, because we built our model, and then we want to make a prediction into the future. We don't know whether the climate in the future has some similarity with where we trained the model. So if now we again plot this, then these are a bit strange. There must be something wrong with this. I think now we have the problem of uh, excluding uh, the highly correlated variables, because these look quite strange, the values we have here. So I'm just forcing in this exclude V from this, and then we can check that again. Yeah, now it makes sense. When I just use all the variables without excluding, then we were seeing these strange hundreds of values, but we expect the values to be between 0 and 1 from the AOA function. So where we see 1, those are areas that are similar to the values that we used in training the model. For example, Antarctica have low values. Those are values that are super different from the values we use in training the model. This means when you predict Antarctica to be suitable for the species, then when you are making predictions even up to Antarctica, then you should know that the predictor variables, they are very different from the predictor variables that you used in training your model at the points where the species have been observed. This is super important, and this is one of the questions that reviewers and everybody else is normally keeping an eye on, to ask the researcher whether they really considered the fact that future climate is different from current climate where the model was trained. So if you have an output of this, analyze the output of this and say, okay, my model was quite similar to all the regions where I did the training. Enough of that. So I will upload this script the way it is. I'm not going to change anything else. Remember, map edit will allow you to create your region of interest interactively, different from draw extent. We used draw features from map edit package, thanks to the creators of that. The rest basically the same, but of course we avoided raster-based functions as much as possible and only used it in niche where the Terra could not, the sparse raster objects are still not yet working well in terms of the values on the y-axis and x-axis with the niche. It plots, but the axes are not right. With that, I will provide a link below this video indicating where you can get the script, this script here, so that you can also reproduce it. If there is any error, you can let me know. And I think I will keep updating this script whenever there is an update in the package, or if as anybody, I think it's free. You can use this and move forward now, other than saying, I'm using video from Babak Naimi's recording and I'm seeing this error and it's not in his code and blah, blah, blah. So please jump out of that kind of mess and enjoy coding. With those many remarks, thank you, Babak, and your team for creating this marvelous package, which is helping the whole globe. I think it is one of the most used packages uh, because it's flexible, extensible. You can add your things, you can play around with it. And it has got up to 22 machine learning methods, which are already set for you. So yours is just to select which ones you want to use and which ones you don't want to use, and even ensembling them. Because other machine or species distribution modeling tools are basically single model based or method based. They concentrate on one method, but sometimes it's nice to have uncertainty around predictions or around methods and quantify such accordingly. So many thanks to all of you. And yeah, let's keep in touch. As I said earlier, that you can go to the GitHub and learn more about the package. You can go to Bioinformatics and go scroll to the bottom, and then you will see the link to Google group where we discuss most of this. Forget about the Chelsea for now. And yeah, in the CRAN, there is this very, very fascinating SDM PDF documentation, which has got everything. For example, if I want AOA, area of applicability, then it's here. It's here. It's well described, all those functions, and even example normally given. Example. Okay, example is not given in this case, but yeah, normally given with these arguments, you can't miss getting it right. So yeah, thank you so much for your attention and goodbye.